We'll have a class 1 unpaid t-test today. So as usual we have a same formula, t-test is equal to difference mean divided by standard error. But we have data as a question here. In a nutritional study, 13 children given a usual diet plus vitamin A and D tablets, while the second comparable group of 1 to 12 children was taking of usual diet after 12 months of gain in weight in pounds was noted. Can we say that vitamin A and D are responsible? This is the actual question, and we have data of 13 children as well as 12 children. So we'll write it as, so we'll consider x as variable and we'll write down the data. So x has 5, 3, 4, 3, 2, 6, 3, 2, 3, 6, 7, 5, 3. So here we were having n as 13 observations, and so the total of this will get around 52 after adding all these values. So similarly we'll write down the y value also, means y variable of 12 students, y variable of 12 students. So we have a data as 1, 3, 2, 4, 2, 1, 3, 4, 3, 2, and 2, and this is 3. So we have here n as observations of 12, and this total will get around 30. So our very next step is finding the x and x bars. So x value we need to find out the x bar, then we have to subtract the x in that x bar. So we need to find out the value of x bar. So x bar is equal to summation of x divided by n. Summation of x, we have 52 divided by 13, will get around 4. So what is our next step is subtracting 5 minus 4. 5 minus 4 is 1. Similarly 3 minus 4 is minus 1. 4 minus 4 is 0. Like that only, minus 1, 2, minus 2, then plus 2, then minus 1, then 2 minus 2, then minus 1, then plus 2, then 3 plus 3, then 1, and minus 1. So next we have to do is x minus x bars whole square. We need to find out the x whole square of this. So 1 square is 1. Similarly 1, 0, 1, 4, 4, 1, 4, 1, 4, 9, 1, 1. So we need to do this total number, and we need to do this sum of all these numbers, so that will get around 32. So next we have to do is finding y's y bar, and that's a square. So however we have y, we need to find out y bar's value. So here we go, y bar is equal to summation of y divided by n. So summation of y value we have as 30 divided by 12. So we'll get around 2.5. So if we have got 2.6, means we used to consider it as 3 or above 2.5. If below of 2.5, we can consider it as 2. But here we got 2.5, means we in the point we need to calculate including point also. So we have y as value 1, and in that minus 2.5 we'll get around minus 1.5. Like that only we have to subtract. Similarly then minus 0.5, 1.5, minus 0.5, minus 1.5, then minus, sorry, it's 0.5, then 1.5, 0.5, 0.5, 0.5. All of them will get as 0.5 itself, and what we need to do is y bar minus y bar whole square. So we'll get its value as around 2.25. Similarly 0.25, like that only, 0.25, 2.25, 0.25, 2.25, 0.25, 2.25, 0.25, 0.25, 0.25, 0.25, again we'll get same 0.25, 0.25, 3. At the last, what we have to do is we have to add these all values, and what we'll get, we need to keep it here. So in the formula we have t-test is equal to difference mean divided by standard error. But if we need to know standard error, means we need to know standard deviation first. So we need to find out the standard deviation of each. For x and for y variable, we need to find out the standard deviation here. So standard deviation of x we have as square root summation of x minus x bar whole square divided by n. Like that only. What value we have got, we need to put in this. We'll get, so here we got the value as 32 divided by same 12, or so n we have as 13. After doing this simplifying, we'll get around 1.54. Similarly, we need to do the standard error for standard deviation for y variable. So square root of summation of y minus y bar whole square divided by n. So we know the y and y this summation value as 11 divided by 12. So after dividing, we'll get around 0.9 square root. So after simplifying this, we'll get 0.95 itself. So next we need to do standard error. Standard error we have as formula for unpaid t-test. Standard error formula summation, this is sigma 1 square plus sigma 2 square, sigma 1 square sigma 2 square divided by n1. Here is n2. So it means nothing but n1 is first variable x1 and this is this is of y's. So next step we have to do is what value we'll consider. This we'll consider is sigma 2 value, and this we'll consider it as sigma 1's value. This one. So we'll put that value in this summation of square root of. So we have it as 1.54 whole square divided by 13 plus 0.95 whole square divided by 12. So we'll simplify this. We need calculator for all these because accurate answers. Plus point we'll get as 0.07. Then again we need to simplify this. After simplifying, we'll get around 0.253 is equal to 0.5. So we have got the standard error. Another method is also there for calculating this, like to calculate standard error for unpaired data. So next standard, after finding out the standard error, we need to do this by using a table t-test, and mean difference we have as first one as x bar value and y bar value. So x bar we have had 4, and in the subtract y bar value, so divided by 0.5 as a standard error. So we'll get around 1.5 divided by 0.5 is equal to 3. So the calculated t value is 3. So the very first step is we need to frame an h0 here before starting the calculation. We didn't frame. So there this h0 says that there is no significant difference between weight gain between children's of group A. Will consider it as x, and with usual diet plus vitamin A and D. For group B and for group B, or else we used to consider it as Y group, usual diet, nothing we added in this. So this says that there is no difference between group A and group B. So we need to find out the degree of freedom for this calculation. So degree of freedom is equal to n1 plus n2 minus 2. So n1 we have add 13 plus 12 minus 2, so which is equal to 23. So we have a degree of freedom as 23. At the level of significance at 0. It's critical value or t table value, level of significance at 0.05, table value is 2.07. So this table value, critical value and calculated value, when the critical value is less than the table value, our h0 is rejected here. So we'll write an inference the significance level at 0.05 table value is 2.07 and calculated t calculated value or t test value is 3. So which is more than critical value or table value? Critical value. So our H naught is rejected here. Then we need to frame H alpha or else alpha H alpha or H alternative hypothesis we need to frame. So this H alternative hypothesis or alpha hypothesis says that there is a significant difference between the children or else group A weight gain in group A with usual diet plus vitamin A and D diet is more than the group B of usual diet. So there is a significant weight gain in group A compared to group B children's. So here we completed an example for unpaired t-test. So I said another method for calculating for standard error and we'll discuss in another one, and if any doubt comment it down in the comment box.